In the late 1930s, steam continued to rule the rails in America, but its glory was fading fast. The mighty locomotives that once powered industry now drained railroad budgets with endless maintenance, coal, and manpower. The system was being pressed under its own weight, desperate for change. This is where EMD stepped in, a young division of General Motors, GM, with a staggering idea. What if a locomotive could be powerful, efficient, and easy to maintain? The answer arrived in a compact, sleek F-unit. The industry didn't know it yet, but this streamlined diesel would become the executioner of steam. The F-unit revolution was waiting on the rails, and steam locomotives were running out of time. Early rails and the struggle of steam. For about 100 years, steam was the heartbeat of American railroads. Every whistle and plume of smoke symbolized progress, and behind it was an army of firemen, engineers, and mechanics who knew every hiss and rattle by heart. The entire rail system, composed of the infrastructure, supply chains, and workforce, was built around steam. But beneath this romance, cracks were forming. Steam power was expensive. Each locomotive demanded tons of coal and thousands of gallons of water for even the smallest routes. Maintenance was brutal because boilers needed constant cleaning, valves wore out fast, and entire locomotives required overhauls after just a few thousand miles. Keeping them alive wasn't engineering, it was endurance. By the 1930s, railroad officials were drowning in costs. The Great Depression and increasing labor demands made steam unsustainable. Then, World War II came, a period of unprecedented industrial mobilization. Advances in automotive and aviation technology created engines that were lighter, stronger, and far more efficient. Suddenly, railroads saw what other industries already knew. Internal combustion was the future of motive power. Before EMD's sleek F-units arrived, diesel experiments were already underway. Companies like Alco and Baldwin built boxy prototypes that proved the capability of diesel, but lacked the cutting-edge refinement expected. Some railroads tested early switcher diesels in the yards. They were certainly reliable, but they lacked the power for long-distance trains. It was clear diesel would work, but they hadn't yet figured out how. EMD's preparation and entry. Long before diesel locomotives hit the rails, EMD was already quietly preparing for a revolution. In the 1920s, the Electromotive Company was a small firm building gas-electric railcars, but they wanted more. Then General Motors, GM, saw the potential. In 1930, GM bought both Electromotive and the Winton Engine Company, merging Winton's diesel expertise with GM's massive production power. 1 decade of testing, failure, and refined designs followed. The Winton 201A diesel engine was EMD's first real test. It wasn't perfect, prone to overheating and mechanical stress. However, it powered the early switchers and streamlined passenger trains like the Pioneer Zephyr, proving that diesels could reliably and efficiently run trains. EMD learned quickly, feeding every failure back into design improvements. They focused first on small switchers and passenger units, slowly integrating diesel into the railroading ecosystem, rather than declaring outright war on steam. Their early E-Series passenger locomotives started gaining attention in the 30s. Every successful performance, from streamlined passenger trains to dependable switchers, built confidence among railroad officials. When EMD introduced the F-unit in 1939, the groundwork had been laid. They were no longer a new company. Instead, they were a proven industrial force with the money, technology, and reliability of GM steam still dominated the rails, but the tide had turned. EMD wasn't coming to compete, it was coming to replace. If nothing else, the F-unit was a clear signal that the diesel age had arrived, good and proper. And it arrived because of the F-unit, the birth of the F-unit. When the EMD F-unit was unveiled in 1939, it wasn't just another diesel locomotive, it was the steam killer. The first model, the FT, was born from EMD's vision to create a diesel powerful enough to handle heavy freight, yet reliable and easy to maintain. Its beating heart was the 16-567 engine, named for 567 cubic inches of displacement per cylinder. This was by no means a prototype, it was a purpose-built, mass-producible freight locomotive. The FT delivered 1,350 horsepower per unit and could be coupled in multiple sets. There were cabbed A units and cables SB units. This allowed railroads to scale power as needed. Aesthetically, the FT introduced a design language that would define EMD's diesel era. a streamlined full carbody cab with a distinctive bulldog nose. It was aerodynamic, powerful looking, and instantly recognizable. Beyond the look, it had substance. The Blomberg B2 axle truck design introduced here offered a smooth ride, improved traction, and reduced maintenance. The FT hit American rails just before World War II, and EMD used that time expertly. The war effort demanded efficiency, reliability, and quick turnaround times, three key components steam engines could no longer provide. The FT proved it could haul freight with less fuel, fewer crew members, and virtually zero downtime. By the time the war ended, railroads had seen enough. Diesel was the future, and the F-Series was the product line leading that change. Following the massive success of the FT, with more than 1,000 units sold and orders placed by virtually every major American railroad, EMD had established its dominance in diesel technology. Railroads that once relied on steam were now scrambling to dieselize their fleets, and EMD had to keep up with the demand. The F-Series succession. Then came the F2 in July 1946, arriving just as the world transitioned from war to peace. It bridged EMD's wartime production and post-war expansion, carrying most of the FT's proven DNA, but introducing the enhanced 567B engine, rated for 1,350 horsepower, along with the new D8 main generator, which boosted electrical reliability. Visually, it looked similar to the FT, but featured cleaner lines and a simpler build for easier maintenance. The big win here wasn't power, it was standardization. The F2 introduced design elements that made servicing and coupling units much simpler, especially as many railroads were now mixing A and B units freely. Though only 75 F2s were built, they played a vital role in keeping EMD's production line running smoothly as the company transitioned into its major post-war models. The F3, introduced later that same year, marked the real beginning of the F-unit's widespread success. The F3 received smoother side grills and distinctive chicken wire ventilation, making it instantly recognizable. But its true genius was under the hood, with improved traction motors, a superior electrical system, and simplified maintenance, making it a favorite among railroad workshops. For many railroads emerging from wartime fatigue, the F3 offered something steam couldn't: predictable costs, minimal downtime, and performance equal to or exceeding heavy steam locomotives, like the 2-8-2 Mikado or even 4-8-4 Northerns. And if the F3 was a hit, the F7 took EMD's success to the next level. This model became the most popular of all F units, with over 2,300 A units and 1,400 B units built. It represented the peak evolution of the 567C engine, retaining 1,500 horsepower, but featuring improvements in cooling, wiring, traction, and maintainability. The F7 became the face of the post-war American railroad. It hauled freight and passenger trains alike with a reliability that was almost mythical. Its Blomberg B trucks provided superb ride stability, and its modular construction meant parts could be swapped out in hours rather than days. For many engineers, the F7 was the locomotive that just wouldn't quit. EMD's nationwide service network and GM-backed marketing pushed the F7 onto the roster of almost every Class 1 railroad. The war bonnets of Santa Fe, the black and white livery of Southern, the royal blue of the B&O, all sported the same iconic silhouette. The F7 was a symbol of America's post-World War II technological triumph and industrial refinement. By the time the F9 arrived on the market, the war against steam was largely won by diesel. The F9 was a refined evolution, the final version of the Bulldog nose freight diesel. It included the advanced 16-567C prime mover, producing 1,750 horsepower, with better traction motors and dynamic braking for hilly territories. The F9 featured slightly revised side panels, smoother body lines, and refined grills. Down below, it was stronger, quieter, and more fuel efficient. The F9 also symbolized the end of an era. As railroads began to prioritize road switchers like the GP7 and GP9, the classic carbody cab design faded from new orders. And there is no doubt that these locomotives had a high degree of importance. Market impact. For decades, steam locomotives tied operations to endless maintenance schedules, massive coaling towers, and around-the-clock crews. Now, here came a diesel-electric locomotive that could be started in minutes, run all day, and quietly sleep in the yard without a single shovel of coal being added. The difference was night and day. Steam required large crews just to start, a fireman to manage the boiler, an engineer to control the throttle, and an army of shop workers to keep it all running. The F-unit changed that equation overnight. An engineer could start it with a single switch. No waiting for boiler pressure, no need to dump ashes, no need to fill up with water every 100 miles. Just clean, reliable horsepower on demand. Railroads quickly figured out that one diesel could do the job of 2 or 3 steam locomotives while slashing labor and fuel costs. It was a miracle. Maintenance was another revolution. Steam locomotives required major overhauls every few months. EMD's F-units could run for years with only routine servicing. The modular design of the 567 engine made replacing parts simple. A cylinder head could be replaced without disturbing the others. This predictability became a goldmine for railroads desperate to reduce downtime. Then came fuel efficiency. Diesel fuel offered more energy per gallon and could be distributed more easily than coal. The result was a staggering drop in operating costs. Period records show F-units consumed up to 40% less fuel than comparable steam engines while hauling the same tonnage. For both accountants and engineers, that number alone made the decision inevitable. Reliability sealed the deal. While competitors like Alco and Baldwin struggled with mechanical teething problems, EMD's F-units simply kept going. Their simple 2-stroke design and dependable root blowers made them ideal for the brutal day-in, day-out demands of mainline freight hauling. Crews liked them because they started every morning without fuss, and management liked them because they stayed out of the repair shops. Railroads that had once hesitated soon began placing bulk orders. The Santa Fe Railway was one of the first major converts. Its iconic red and silver war bonnet F-units were incredible pieces of machinery. The Union Pacific followed suit, ordering a vast fleet of yellow and gray F-7 to replace their heavy freight steam locomotives. Soon, almost every major line, from the Great Northern to the B&O, was running some form of EMD F-units. And it wasn't just freight. EMD designed passenger-equipped variants fitted with steam generators, allowing the F-units to heat and power passenger cars. Suddenly, diesels weren't just confined to the yard or freight. They were pulling America's most prestigious trains, from the Empire Builder to the city of Los Angeles. The longevity of these locomotives became part of their legend. Even after production ended in 1960, railroads didn't scrap them, they rebuilt them. Spare parts were abundant, and EMD offered complete overhaul programs, often upgrading older 567 engines to newer 645 standards. Many F-units were rebuilt into GP series road switchers, while others found a second life on branch lines, short lines, and even tourist service, where some still run today. Steam's fall and the railroad industry shift. By the 1950s, steam simply did not pay. Multiple steam locomotives were simultaneously outclassed by a single F-unit using fewer resources. The numbers did not lie. The cost per mile for diesel was roughly half that of steam. The ripple effects were immediate. Railroads that had once employed thousands of boilermakers, firemen, and hostlers began shuttering steam shops and coaling towers. Diesel required an entirely different ecosystem, where compact refueling stations replaced sprawling coal yards, and mechanical departments retrained to handle electrical systems rather than boilers. It wasn't just a technological shift, it was a cultural one. Generations of workers trained on steam found themselves forced to adapt or step aside. For EMD, this was an opportunity in motion. Led by the F-units, they didn't just sell locomotives, they sold a complete transition package. General Motors offered training programs, spare parts logistics, and even mobile service units that followed the locomotives along the routes. Railroads no longer had to guess. They could tap directly into GM's industrial backbone. That kind of corporate support was something steam manufacturers could never replicate. But competition was brewing. Companies struggled to produce their own diesels. Some designs were more powerful, others more advanced, but by the time they hit the market, EMD had already cemented its reputation for reliability. Railroads were no longer just buying locomotives, they were buying peace of mind. Government and labor pressures also played their part. Post-war regulations demanded cleaner, more efficient transportation systems, while unions pressed for safer, less grueling working conditions. Diesel-electric locomotives checked every box. By the mid-1950s, the great steam fleets were quietly vanishing. The locomotives that once thundered across the continent were scrapped by the thousands, replaced by the sleek F-units that could run coast to coast without breaking a sweat. But this all came with a certain set of limitations. Overcoming challenges and limitations. As right as the F-unit felt, it was not without its drawbacks. What made it sleek and aerodynamic on the open track also made it a headache in certain jobs. In yard work or switching duties, visibility was a nightmare. Engineers struggled to see the couplers or the ground crew during maneuvers. The beautiful curves that looked so good in photographs came at a real operational cost. Crew complaints mounted across the railroads. The F-unit's cab layout gave engineers a narrow forward view and almost no rear visibility. When coupled in multiple units, the trailing locomotives were effectively blind boxes. Yard workers joked that the F-unit would drive itself into the fog. For road freight, this wasn't a major issue, but for switching and local service, it was a serious problem. Then came another limitation: flexibility. The F-unit's carbody design meant that for any significant maintenance, the entire locomotive had to go into the shop. Removing internal components often required lifting the roof or cutting panels, unlike newer designs where the engine and components could be accessed directly from the sides. This wasn't a huge problem when EMD's reliability was legendary, but over time, railroads began to crave a design that was easier to service and better suited for mixed operations. By the mid-1950s, EMD engineers began rethinking the F-unit's design. The solution arrived in the form of road switchers, locomotives with a narrow hood and side walkways that gave crews 360-degree visibility and much easier access for maintenance. The first of these, like the GP7 and the GP9, borrowed the same reliable 567 engine that powered the F-units, but wrapped it in a far more practical body. These general-purpose units became the next evolutionary step in locomotive design. Nevertheless, F-units didn't fade away overnight. They continued to dominate mainline service well into the 1960s, hauling freight and passenger trains with the same dependable rhythm. And it is the dependability of the F-units that made its legacy great. Legacy and lasting impact. The F-unit didn't just end the steam era. It defined everything that came after it. Its success set the blueprint for the diesel age. It was mass production built on reliability, not reinvention. EMD had proven that a locomotive could be designed like an automobile and reproduced by the thousands without sacrificing quality. Every subsequent manufacturer, from Alco to GE, had to follow those rules. Design-wise, the F-unit's DNA lived on. Its internal layout, known for a compact power plant, modular electrical systems, and the ease of multiple unit control, became the backbone of the hood unit revolution that followed. The GP7, the GP9, and later the SD series locomotives trace their roots back to the lessons learned from the F-unit's triumph. Even decades after production ended, the F-unit refused to disappear. Many units found a second life on short lines, industrial railroads, and later in preservation. Today, dozens of gleaming F7 and F9 still thunder across heritage railways and museum routes throughout North America. Their engines echoed the heartbeat of an era that transformed railroading forever. More than a machine, the F-unit became a symbol of progress. It became a reminder of when American industry proved it could outthink and outbuild its past. It bridged two worlds: the romance of steam and the precision of diesel technology. The EMD F-unit was a lesson in engineering discipline. It showed that progress isn't always about chasing the newest idea, but perfecting the right one. In an era when many clung to the romance of steam, EMD bet on consistency, precision, and patience. That changed the trajectory of an entire industry. The F-unit taught American manufacturing that evolution often wins over revolution. It rewarded companies that tested, refined, and trusted their designs instead of rushing to reinvent. Its streamlined shell and reliable heart embodied a new industrial philosophy, one where every bolt and bearing had a purpose, and where reliability became the ultimate selling point. By the time steam disappeared from the rails, the F-unit had already written its legacy. It wasn't just the diesel that killed steam. It was the machine that taught America how to build for the future.